In this FRQ question from 1988 AP Physics B, now these topics are covered in AP Physics 2, they say that a triangular prism shown in figure 1 above has index of refraction 1.5 and angles 37 and 53 degrees and 90-degree right angle. And the shortest side of the prism is set on a horizontal table, and a beam of light, initially horizontal, is incident to the prism from the left. On the figure 1 above, sketch the path of the beam as it passes through and emerges from the prism. So in this case, when the ray of light is incident perpendicularly to the interface between the two transparent mediums, it enters the new medium without bending. So in this case, the light that is coming into the prism will stay straight because it enters perpendicularly to the new medium. As for the ray that is coming out, I need to have a perpendicular or normal to the surface where the light is coming into the new area, which is the air coming out of the prism. The angle of incidence, this would be the angle of incidence with the normal to the surface where the light is coming out, and the air is thinner than the prism, so the angle of refraction is going to be bigger than the one that is the angle of incidence. So this coming out angle with the normal is going to be bigger than the one that of an incidence. For the next question, they say determine the angle with respect to the horizontal angle of deviation of the beam as it emerges from the prism. So they want you to find the angle of refraction, this one, the one from the normal with the surface. So in this triangle, this angle is the same as the incidence angle. So this angle is the same as that angle. They're vertical angles. And then if I make my perpendicular line to the surface that where the ray is coming out longer, then I get this angle is the right angle. Then this one has to be 53 degrees. So if this one is 53 degrees and this one is normal, then the incident angle is 37 degrees. And this part is 37 degrees. And I can use the Snell's law to calculate this angle, that angle. I'm going to call it angle theta 2. So I have index of refraction in the prism 1.5, sine of 37 is equal to index of refraction in the air is 1, and then I have sine of theta 2. And if I want to calculate my theta 2, that's gonna be arc sine of 1.5 sine of 37 degrees. And theta 2 is equal to 64.5 degrees. So this whole angle right here is 64.5 degrees, but this little angle away from the direction where the ray was coming, let's call it alpha. So that angle is equal to 64.5 minus the angle that we said right here, which is equal to 37 degrees. So that's 37 degrees. So I get alpha is equal to 27.5 degrees. And what they ask you in B is to find the angle of deviation from the direction of where the angle was coming from. So they ask you to find just that angle, which is 27.5 degrees. For the next part, for C, they say the prism is replaced by a new prism of the same shape, which is set in the same position. The beam experiences total internal reflection at the right surface of the prism. What is the minimum possible index of refraction of this prism? So what's happening is the light is going this way, and when it reaches the right side, I'm again gonna draw the perpendicular line or the normal to the surface of the right side. It's gonna experience the total internal refraction. So it's gonna be this one, and this angle right here is gonna be 90 degrees. And they ask you what is the new index of refraction of the light. So for the Snell's law, I have index of refraction of the prism, and then sine of angle of incidence, which is, we already know, 37 degrees, is equal to index of refraction for the air, which is 1, and sine of 90 degrees because it's coming out at 90 degrees with the surface. So I have the new index of refraction is equal to 1, because 1 times sine of 90, which is 1 as well, divided by sine of 37 degrees, and that will give me 1.66. So the new index of refraction of the new prism is 1.66. For the next question, let's see what's here. They say that the new prism having the index of refraction found in part C, and that is 166. And so what they are saying is, the new prism having the index of refraction found in part C, which is 1.66, is then completely submerged in water. Index of refraction of the water is given 133 and shown in the picture. Now, the horizontal beam of light is again incident from the left side of the prism. So on the figure 2, sketch the path of the beam as it passes through and emerges from the prism. Because now the water has greater than air index of refraction and the beam is entering perpendicular to the prism, the first part is going to be the same, not change compared to the one that was before. And then if we have our normal to the surface where the light is coming out of the prism, the beam is going to be exiting. So let me mark this one. This is the angle of incidence. Because index of refraction of the water is greater than the air, then it's not going to be, so this angle is still going to be bigger than the one that is incident with, but it's going to be smaller than the one that we had before. So I'm going to make it maybe like this. So you see, before I made it farther away, so the first case was something like that, and now it's going to be closer to the normal compared to before, because the index of refraction of the water is 133, not 1. And again, I have this angle is the same as that angle, which is 37. So index angle is 37. And they ask me this one, alpha, to find that one. So I still have to do the Snell's law. So I have index of refraction of the prism, which is 166. The sine of 37. And that is equal to index of refraction of the water is 133. And then I have the sine of the angle of refraction, which is this one. Let's call it sine theta 2. So theta 2 is going to be equal to 160. Oh, it's arc sine. So it's going to be arc sine of, and then we're going to have 1.66 sine of 37 divided by 133. And that will give me the angle of refraction equals to 48.7 degrees. But if we just looking for this angle alpha, so angle alpha is going to be equal to 48.7 minus 37 degrees. So that will give me 11.7 degrees. So you see that this angle is smaller compared to the one that we had earlier. And for the next question, they say determine the angle with respect to the horizontal angle of deviation. Okay, so that's the part that we already found. So that would be the part in E. And I think that's all that we have for this question from AP Physics B 1988 FRQ question. And thank you for watching. Subscribe if you like, and I hope I see you in my future videos.